Welcome back to our live training session. In this tutorial, we're going to be taking a look at doing cold start tuning with our ethanol fuel in the fuel system. So we've already mapped everything out using the flex fuel feature. Now we're going to be testing things when the engine has been left overnight so it's bone cold. We need to see if our cranking enrichment needs to be adjusted or not. We'll see how the engine's going to crank and fire. We might find that we need to add some more fuel. We'll talk about what we did to prep ourselves for this tutorial, kind of where we're at, and then we'll talk about when we actually fire it off what we need to adjust. We'll also look at the warm-up enrichment as well, seeing if we need to tweak or adjust anything with ethanol in the system now. The other things we're going to take a look at setting up an oil pressure sensor and setting up and working with a normalized knock mode. So we've already set up the traditional style knock control. We know it's all functional. Now we're going to experiment and turning on the normalized. I have a tutorial in the main training course already talking about working with the traditional and normalized. We're going to take a look at doing the normalized on our vehicle here. So a lot of things to unpack. The other thing I want to take a look at doing here, if there's going to be time, it's going to be setting up the gear detection. I was able to verify the speed sensor does work, so everything is functional with that. So we need a speed sensor that's calibrated, and then we also need to go into the gear detection mode and then manually set that up. It's super easy and simple. That'll allow us to set up our gear biasing for boost control, and we'll talk about that routine here as well in this tutorial. So let's first take a look at a few things, talk about setting some things up here, and then we'll fire off the engine and see what we have for oil pressure, looking at the normalized knock, and then also looking at our cranking fuel here. Okay, so first things first, let's talk about our cranking fuel and flex fuel. If we go into fuel trim here, we find that we have our crank enrichment table. Now this table is based on our multi-fuel blend ratio. If we go here and see on our axes here, 10% to 90%. That is based on ethanol percentage from 0 to 100. If we go here to our layout and we drop down into flex, we're going to find we have our multi-fuel blend ratio table. Again, this table is based on ethanol percent from 0 to 100, and then it's also in the table configured as a 0 to 100% scale. So, knowing this, jump back into our, let's go to layout, let's go here to our fuel trim. This table is essentially looking at our ethanol content sensor. So we know on a cold engine, we verified that the engine is able to crank, fire, and run fairly well on petrol fuel. This 10% row here is essentially representative of our petrol fuel. Now on ethanol, we're going to be finding ourselves biasing more towards this 90% ethanol. Now we're only at 55%, but it's going to interpolate between these two. If we were on 85, 90% ethanol, we would find we have to at least double or triple what we have for our petrol fuel values on a cold engine. And that's due to the poor atomization of fuel as it's spraying out of the fuel injector, specifically on ethanol. Petrol, it's improved, although it's still a problem. This is why we have to have a little bit more cranking fuel on cold engine on petrol, but it's exaggerated on ethanol. It's even worse. So we need to go overcome that, and we need to crank up our injector pulse width. So again, 2 to 3 times is pretty normal on ethanol E85 or higher compared to petrol cranking pulse width or cranking values that we have. So we can see I've doubled that. Now I specifically only focus on really doubling everything when we are here at 86 degrees and below. That's where I consider the engine to cranking off cold. Once the engine is warm, I'll consider that to here to be about 140 and warmer in engine coolant temp. Notice that the values in our table are the same between the petrol and ethanol rows. That's because we don't need any further fueling delivery when we're on ethanol for our cranking fuel. Fuel's going to atomize the same as it would on petrol fuel on a warm engine, so we don't need to go in and have to have that multiplier. So what we're going to be testing right now when we fire off the engine is if the values that we have in this row are valid or not. If we need more cranking fuel, we're going to know this because the engine's going to take more cranks to fire off compared to petrol. So if it takes maybe 10 cranks to fire off or multiple crank attempts, that's a dead indication that you need more cranking fuel and you need to raise up your values, probably go up and raise them at least 50 to 100% higher on your colder status, wherever you're going to be at here in the engine coolant temperature. If you crank, fire, and run fairly well, just as you would on petrol, then your values are valid. You don't need to go and increase them and touch them. So we'll see how this is going to go. Again, as a starting point, I went in, whatever my petrol fuel values were, I just copied them, pasted into that row, and then I multiplied by 2. I doubled the values. That's always a solid starting point. Okay, discuss all that. Hopefully that makes sense. So we'll test this out and see if we need to increase our cranking enrichment here on ethanol. Now let's go here. Let's take a step back in our windows. Let's go here to analog input, and we're going to go here to the oil pressure. Now, I've installed a 0 to 150 oil pressure sensor on my oil sandwich adapter. I actually had another oil pressure, oil temperature sensor combo on that thermostat, but I found that I had all kinds of weird problems with the sensor. The sensor itself, I think, was damaged, and I can't remember the brand of the sensor, but it wasn't going to work. So I didn't even include that when we set up our base map or looking at any of that sensor data, because the sensor itself was definitely a problem. Oil pressure was constantly showing 5 volts out of the sensor. It was wired correctly. I double, triple checked everything. Even oil temperature out of that same sensor was really weird. It was skipping around a lot. It was really a noisy sensor. So I think the sensor was bad. So I've went in and I've installed just an oil pressure sensor in the same location. It's a 0 to 150 psi stainless sensor. It's a no-name brand sensor. I don't know if it's going to work or not. I actually have 2 of them because they were fairly cheap. I just wanted to get something in here for filming and to show you this demonstration. We'll see what it looks like when we actually program it here, but we do need to set this up. Now, I've wired it in under analog input 8, so I need to note that and set the scale, and then we can actually see how it's going to read. Right now, we can see the oil pressure channel here is showing 0. I want to set up an oil pressure failsafe protection in this tutorial to show you how to do all that. And to verify oil pressure is good, but we obviously have to program it right, make sure the scaling is right. So let's go here to source, and I'm going to go in here, and I'm going to grab analog volt 8. That's the only analog volt that's open right now. There's a low and a high error. I'm going to set this, it's a 0 to 5 volt scale, specifically half volt, 0 psi, 4.5 volt, 150 psi. It's pretty simple linear scale sensor. Most pressure sensors are going to be like this. I'll set my minimum or my low error here if it drops below, let's say, 0.35 volt, and then the high, since I know the maximum voltage we should see out of the sensor is a 4.5, I'll go up to something like 4.65 just so it can detect an open circuit. Now the error value, if it faults out, we can say something like, let's say, 100 or even 200 kPa. Now the calibration here, we want to go ahead and select this. Looks like it actually automatically set itself on 150. That's actually what I have here. So if we click OK, we take a look at the oil pressure reading. That's a little bit suspect. It's showing here about 100 kPa coming out of the sensor. Now, the sensor that I'm using is a cheapy sensor. It could be a PSI-A sensor and not a PSI-G sensor. The atmospheric pressure reference would be like a map sensor. So I don't know if this is a PSI-A. We take a look. The barrel pressure, atmospheric pressure right now is showing about 100.1. The oil pressure is pretty close to that. When we fire off the engine, we'll have to see what that looks like. You ideally want a PSI-G or a gauge pressure reference or a sealed sensor, so it's not going to be influenced as your elevation or barrel pressure changes. It's not going to influence what the pressure sensor is registering reading like a map sensor would. So this sensor itself could have been passed along as a gauge sensor, and it's actually an atmospheric pressure reference sensor like a map sensor. We'll see when we fire it off. We can make it work, but definitely want a PSI-G sensor, so I'm probably going to have to go in and change the sensor down the road here. But at least we've scaled it, so we've set everything up there. Now let's talk about, and what I want to do is save this real quick. I want to go in here and save this. I'm going to just call this normalized knock, since this is our flex fuel tutorial. That's our last one. Just so I know the difference here, so I'll call this normalized, because I'm going to be changing the knock control over, which is going to essentially get rid of our traditional programming, and that is still useful if I want to flip back and forth. I want to make sure I have file saved there, so I'm not just completely overwriting what we've done for the knock control. So let's go here into knock. This is our traditional window. We've set up our knock threshold table here. We know that it was valid. We have a Bosch flat response knock sensor. Now normally when I was doing filming with this car, I had the resonant OEM style sensor, which is typically pretty noisy out of the sensor, although it was behaving fairly well when we were doing our tuning. Now that we have a Bosch flat response, I am willing to switch over to the normalized knock mode. The resonant sensors, because they are noisy and are loud, they produce a lot of amplitude output, that is problematic with the normalized knock mode. We want to run a Bosch style flat response sensor. I've switched over to that style sensor, so we should be able to implement this normalized mode now successfully. The difference between...
Thanks for checking out our teaser clip. If you want to see the rest of this video and more than 500 hours of current EFI training we have to offer, make sure you click right here. If you want to go and check out more teaser clips from this training course, click here, and you don't want to miss any of the videos we're going to be releasing on this channel, so make sure you subscribe and click here. Thanks for watching, and I'll see you guys later.